All right, good morning, everybody. We're going to start chapter 15, homework assignments right now. So let's look at the first one. Evaluate the iterated integral from -3 to 1, from 0 to 1 of 35 x to the 6 y to the 4th dy dx. So this is 15.1, question 1. Iterated -3 to 1, 0 to 1, 35 x to the 6th y to the 4th dy dx. So what this one says is since dy comes in first, we have to take it with respect to y. So we have 35 x to the 6th, the integral of y to the 4th is y to the 5th over 5 from 0 to 1. So 5 goes in there 7 times, so it's 7x to the 5th, x to the 6th, y to the 5th from 0 to 1. So it's 7x to the 6th, 1 to the 5th, because we're doing with respect to y. So these are the y values. Minus times 0 is 0. So we get 7x to the 6th. Times 1. So now we have to take this integral from -3 to 1 with respect to x. So the integral of x to the 6th is x to the 7 over 7 from -3 to 1. Yeah. 7 times these cancel, so it's 1 to the 7th minus -3 to the 7th. So it's 1 minus, let's see what -3 to the 7th is. Calculator. So we have -3 -3 to the power 7. Is -2,187. So that becomes positive 2,188. So that's the first answer. 2,188. Right, number 2. Evaluate this double integral 9x plus y dx dy. Zero to 3 from -2 to -1. 9x plus y dx dy. We have to take this integral with respect to x. So this is with respect to x. So the integral of 9x with respect to x is 9x squared over 2 plus xy. That's from -2 to -1. So let's look at this one. 9 times -1 squared over 2 plus -1y minus 9 times -2 squared over 2 minus 2y. -1 squared is 1, so 9 over 2 minus y. -2 squared is 4. 4 over 2 is 2, so it's minus 18. Negative is positive 2y. So this has to be 36 over 2. So 9 minus 36 is -27 over 2 plus y. So now we take that with respect, integrate it with respect to y. -27 over 2 plus y dy. So that becomes -27 over 2y plus y squared over 2 from 0 to 3. Since it's to 0, so always have to do the top. -27 over 2 times 3 plus 3 squared over 2 minus 0. 27 times 3, -81 over 2 plus 9 over 2 plus -72 over 2, which makes it -36. And that's that answer. All right, number 3. Evaluate the iterated integral with respect to y and with respect to x of x cosine y. So that's with the x, that's with the y. Number 3. We have from 3 to 5, from pi to 3 pi over 2. X cosine y dy dx. So this one is with respect to y first. You remember the unit circle. Up here, it's sine, cosine, negative sine, negative cosine. So with derivatives, we go this way. With integrals, we go that way. So the integral of cosine y is from here x sine y. From pi 3 pi over 2 dx. So this inside becomes, we're only doing with respect to y because we haven't touched the x yet. Sine 3 pi over 2 minus x sine of pi. Sine of pi is 0. So don't have to worry about that. Sine of 3 pi over 2 is -1. That is -1 because this is 1 pi over 2, 2 pi over 2, 3 pi over 2. It's negative sign. So it's -1. The integral of negative cosine is negative cosine squared over 2 from 3 to 5. Negative 5 squared over 2 minus negative 3 squared over 2. Negative negatives are positive. So they're both over 2. So we have negative 25 plus 9. It's negative 16 over 2 equals -8. So that's that volume. Okay, question number 4. Double integral of y x to the 4th over y squared plus 1 dA. All right, this is an interesting one because remember, it all depends on how you choose to integrate it, whether it's dy dx or dx dy. And if you noticed, they left that up to us to decide. Where the range is from 0 to 10 on the x, 0 to 1 on y. Since we have a whole bunch of y's, that will save for the next round. Right now, I would want to integrate with respect to x first. So what we're going to do, the outer one is going to be the y, and the inner one is going to be the x. The x dy. That's Fubini's rule. We can choose any order of integration. Since we only have one x, the rest of the stuff is a constant for this first round. So we just have to integrate this one. The integral of x to the 4th is x5 over 5 from 0 to 10. Yeah, this is only has to do with x, so we don't have to worry about the rest of this stuff just yet. We just have to worry, the bottom 0 doesn't matter, so it's just the top we're going to worry about. 10 to the 5th over 5 y squared plus 1 dy. 10 to the 5th is 1 with 5 zeros behind it. So that divided by 5 is 20,000. So it's 20,000 y over y squared plus 1. Since we have a y squared plus 1 and a y on top, remember the derivative of u is 1 over u du times the derivative of whatever's inside. So if we had the ln of y squared plus 1, the derivative would be 1 over y squared plus 1 times 2y, which is almost identical to this. We have the 2. The 2 is 2 times 10,000. So we have this exact combination. So our integral is 10,000 times ln y squared plus 1 from 0 to 1. Ten thousand. The first one, we have ln 1 squared plus 1 minus ln 0 plus 1. One squared is 1 plus 1 is ln 2. 0 plus 1 is 1. ln of 1 is 0. So our answer is 10,000 ln 2. Right, so we put that in our answer. $10,000 ln 2. Question number 5. Find the volume of the region bounded above by the perimeter, the paraboloid. Z equals x to the fourth. Z equals 4x squared plus 2y squared. And below by the region R. Okay. So we're talking about the integral of 4x squared plus 2y squared. Yeah, it doesn't matter which way. So we could do it dx dy. So remember, our region is from -2 to 2 and from -2 to 2. I'm doing first with x. So leave the y alone. So the integral of 4x squared with respect to x is 4x cubed over 3. And the integral of 2y squared with respect to x is 2x y squared. -2 to 2. So we have to find this value first. Four times 2 to the third over 3. 2 times 2 y squared minus 4 times -2 cubed over 3 plus 2 times -2 y squared. It's the first and second with respect to x. 2 cubed is 8 over 3 plus 4y squared That's 4 times -8 over 3 minus 4y squared. (32 over 3 plus 4y squared). Negative 32 over 3, so it's positive 32 over 3 plus 4y squared. 32 over 3 plus 32 over 3 is 64 over 3 plus 8y squared. 4y squared is what that. So that is the inside. So we now have to take the integral with respect to y of this function. Which becomes 64 over 3y plus 8y cubed over 3 from -2 to 2. So look at the first top one. So we have 64 times 2 over 3, 8, 2 cubed over 3, minus 64 times -2 over 3, plus 8, -2 cubed over 3, it's 128 over 3. 2 cubed is 8, so that's plus 64 over 3 minus a negative, so that's going to be -128, so it makes it positive 128 over 3. -8 makes it -64, minus makes it positive 64. (128) 28's 256. 64 and 64 make it 128. 256 plus 128. 384 over 3. 3 goes into 3 once. 3 goes in 8 twice, with 2 left over. 3 goes in 24 8 times. So the answer is 128. That's the volume. And last one, use Fubini's theorem to evaluate this function. We got 0 to 3, 0 to 5, 3x e to the xy dx dy. First off, there are too many x's here. If we could integrate with y first, then it'd be much easier for us to look at it. So using Fubini's rule, I could switch the order of integration. 3x e to the xy power. So that means I have to switch the order of integration. Now, all I have to do at the first one, I have to integrate it with respect to y. So the derivative of e to the xy is xe. So there's my coefficient. Don't have to worry about that. So it's 3 XY. Remember, this derivative has to equal that, and it does. That's why we can use Fubini's rule there. So we go from 0 to 5. So it's 3. This is with respect to y first. So it's 3x minus 3, 0. Which now we're going to integrate the second one. 3 e to the 3x minus 3, because e to the 0 is 1. Now, if we integrate it with respect to x, we get the derivative of this is 3x, which is perfect. So it's just e to the 3x, because the derivative of this gives me that, minus 3x, because the derivative of this has to equal that. From 0 to 5. So we have e to the 3 times 5 minus 3 times 5. Now minus 0. E to the 3 times 0 minus 3 times 0. E to the 15 minus 15 minus e to the 0 minus 0. E to the 15 minus 15. E to the 0 is 1. And 0 is gone. So the final answer is e to the power 15 minus 16. E to the 15 minus 16. All right, I hope that helped. See you all in the next homework assignments.